I'm Raj and welcome back to my YouTube channel. So today in this video we will talk about exception handling in Python. So the first and foremost question, what are exceptions? So exceptions are nothing but an unexpected event that occurs while you are running your program or while you are executing your program. So this event can be related to some values, some data types, or whenever you are trying to misuse the rules. So whenever you are doing something in your code, and when you violate the rules or you are trying to misuse any rule, then this exception will occur. So it actually disrupts your normal flow of execution. So whenever you execute your program, your program execution starts from the first line and then it goes on top to end line. But whenever an exception occurs, it actually disrupts your normal flow of execution. So how it actually does, let us see by a small graphic example. So let's suppose we have this 5 lines of code, 5 lines in our code. So the program execution will start from line 1, then we'll go to line 2, and let's suppose that we have this line 3 where something fishy is happening, and that's where the problem is. So whenever we are executing our code will be executed something like this. So we'll start off with line number 1 and then we'll go to line number 2, and then whenever we'll execute line number 3 will be reported and execute an exception. So the program run will stop and it will print whatever the exception that is occurred, and then the program will end there itself. It will not go beyond line 3. So the line 4 and 5 will never execute it. Will never be executed because it is Python. Because Python is an interpreted language. So in interpreter we go the program execution line by line. So if we have an error in some line, then we will not go beyond that line. Which is quite contradictory to C++, where they are more compiler oriented. So in C++, you will go through the code once and you will report whatever the errors that has been detected in the code. But here in Python, we actually stop the code and we report it at that point only. So let's go towards code and find out what are the exceptions that we have in Python. So in Python, we have a library known as Builtins. So the built-in libraries actually contain some of the features about Python. What are the built-in libraries and stuff in Python? So we can use this help function for knowing more about built-ins. So if we write built-ins as a parameter in this help function, and if we try to run it, it will show us a very good output which actually tells about this built-in module. So it will tell about the different classes that exist in Python. So which start from the exception classes to what are the data types, different data types, and what are the methods, etc. What is the memory view, etc., etc. So, but our focus is for today's tutorial is about exception. So we have this base exception class. Then we have this exception class, so which actually contains all the exceptions that are possible in Python. So we have different exceptions available that are starting from arithmetic error, which has error related to, or exceptions that can occur whenever you are performing a mathematical operation. Then we have the attribute error, which tells about if there is an error or in defining an attribute or using an attribute. Then we have the import error and so on up to memory error, like related to files. Whenever you are using multiple files and you try to misuse the file, or you don't read the particular file, or the file does not exist, then those kinds of error are also here listed here. So today we will see a basic one or two of these exceptions, and we will try to handle it in a very good way to so that we don't cut off from program, or we don't stop the program execution while avoiding the errors. Even if we don't have one, we will use, because it is a very good practice to use exception handling, because if you have made the code, but if you give it to your user to use it, and if they ran into an exception, then they can't do anything about it. But as a programmer, we have to make our program more robust. So let's see about how to handle one or two exceptions. So let's try to give you an example what an exception can be. So let's say I have a number 5 and if I divide it with by 0, then we'll have something known as zero division error. So this is an exception, right? So because of this, if I had 10 lines of code, then I will not go beyond this 10. So Python has a very good debugging tool. So here I get what at which line we have occurred this error. So it shows that I have zero division error in this line. So now if I want to handle this error in a very good way so that our program execution doesn't stop, I have to use something known as exception handling, which is the topic of this video. So we'll handle the exceptions using something known as try except uh, block. Try except blocks actually catches the exception, and it can print a custom message or a custom operation based on your user's requirement. So it starts with a try. So we'll write try as like these are the keywords that you have to follow. We'll succeed it by a colon. Then we'll write whatever the code that we feel that it can be of a fishy in nature, and it might cause an exception. That will write the code in the try block, so which is a single tab space away from the original block of code that in which we are writing. So we'll write whatever the code that we have. So this is just a marker code, and then we'll have the except block at the original tab space of try. So here in the except block, we can specify an exception that we are like expecting, or even we can know what exception that it is going to happen. So here you can write about something about exception and how to handle that exception. So this is except block. It's like if else later if you can take it in a normal way. So you define the condition and then you write some code based on that. So if you want to handle that exception, then you have to how you want to handle, then you can write in the except block. That is again a single tab space away. So let me give a small example of how to use the try except block. Let's say we have three variables a, b, and c. So we have values a equals to, let's say 5, and b equals to, let's say 0, and c for now 0, but we will have c equals to something that that is an operation between a and b. And let me write this code in the try catch block. Let's say I write c equals to a by b, so which is basically 5 divided by 0. So that is mathematically not possible. So we want to catch that exception, right? So I can write try and except, and then I will write, I can print a custom message whenever I catch the exception. I can write, let's for example, I will write exception occurred. So if I run this, I will not actually stop the program. I will completely execute the program without showing any error. So this is a very good way to make our program robust. So this was like, if you don't want to know what exception it was, then you can just leave the exception part as empty. If just write except and then follow it by colon, and that will be it. And if you want, you can write the handling part by your own. But let's say I want to know what exception it was, then I can use this exception with capital E and the rest of the characters as lowercase, and then I'll write as E. So I'm using the aliasing as exception as E. So you can write the alias name whatever you want. I am taking E as a, like, for an example. So I can write, I can know what error it was by printing it. So if I run this, then I'll get exception occurred division by 0. So I'm getting an exception of division by 0. Similarly, you can get to know multiple things. Let's say I take this B as something known as ABC, and if I try to do this, then I will get an error: unsupported operand types for integer and string. So you cannot perform an operation between string and integer. That's what I want to say. So that's how you can get to know what an exception can be. Let's say if you know what exception it can be occurred from a certain snippet of code, then you can write the exception name here as well. Let's I change this to again to 0. So if you at some point you might know that the value of b can be 0. Like if this is hard coded, but let's say in your code your values of a are being like updated in between the code, and somehow it might possible that your value of b can turn into 0. So that's where you know that it might go into zero division error. So you can specify that exception here. So zero division error, like with the zero as z is capital, d is capital, and e is capital without spaces. So now that I have defined what the exception is, I can write the code based on it. So I can write b is equals to, let's say I can take the default value of 4, and I can compute it using this way. So let's say a c equals to b, and I print the value that I have changed. So let's say I perform this operation. So now here I have catched the zero division error, and I have used my like the exception code or the handling code that I mentioned. So here I've converted b is equals to 4 from 0, and I now if I have performed this operation, which is 5 divided by 4, then I will get 1.25 because it is a floating point operation. So that's how you can catch a specific error. So here's the catch, right? So you can catch multiple characters by like mentioning multiple except statements. So I can catch let's say attribute error. And I have to write some code for attribute error or whatever I want to handle. And then I can write similarly. I can write the different errors that I expect that it might occur. So that was how to handle multiple known exceptions using except blocks. So here this if you are using the try block, then except block a single except block is compulsory. So you cannot deny even a single except block. But there are two more optional blocks that you can use in your code to have a more robust and more like complete code. So here there are two blocks that you can add up to this code, which is else block and finally block. So remember guys, I told you to compare it with an if else block. So this else here, similar to if else, it will only run when, or this else can be compared with the for loop as well. So in Python, the for loop also has an optional else block. So whenever your for loop does not break, the else part will be executed by default. So similarly to that, if we don't get into an exception in the try block, then this else part will be executed. So I can write, let's say no exception occurred in this way. So this way I can know that my code was ran into an exception or not. This is like, you can use this in a way. You can use it in a different way based on the purpose. So let's say I change this to 3. So now I will get oh sorry, for now I will remove this finally block. So yes, so now I get that no exception occurred because like this code was exception free. So now else block is executed. Let's say I change this 3 into 0, then this print statement will not work because we ran into an exception, so the else block will not be executed. Let's try out about finally as well. So finally is like, in any circumstances, if you write an try except block, and if you mention something in the final block, that will be executed regardless of the exception occurred or not. The final block will be executed. So I can write if I give you a small example about that, so I can write program is ended. So this is like the basic example, but you can use it in your code whenever you face some situation where your programming is going into an exception because of the logic that you have applied. So let's say I run this code. So yes, the final block is executed irrespective of the exception is occurred. Let's change the value. So yes, so that's how you can handle an exception. So that's it in this video, guys. Take care of your health. If you haven't subscribed this channel, please subscribe it. If you like the content, please like it, share it among your friends, and if you have any doubt, please ask in the comment section. Till then, this is Raj signing out.